Welcome back, David. Gonna dig deep into what we feel like is a relevant topic, the biological AI, or understanding how our cells think, program ourselves, and so on, and how is it actually linked to modern things that is AI advancements. And it almost like if you open up your mind and start thinking about it, it feels like we are reverse engineering ourselves into this AI stuff that we already have mastered, but through this process, we try to explain what the hell is happening now. And I want to see if this is somewhat true, like what is programming us, what's happening there, what is affected, and how are these adaptations possible, and so on and so forth.
Yeah. Okay. So uh, the reason why we're going with this topic is number one, it directly mirrors biology. So it's going to be much easier for people to understand, especially because AI is so new that even your, 10-year-old kid knows about AI at this point, right? At this point in our society, AI is all over the world. Everybody's talking about it. Everybody's saying it's going to be the next big thing, and it is, right? All of these things are true, but people are kind of, people that are in the AI space, either investing, making, or making the infrastructure for AI, know that we're a long way from what people anticipate AI to potentially be. So, what stage are we at right now? I would call it we're at the framework that our biology already works at, which is um, an electrical resistance framework. This is what's limiting AI right now. The ability to give it enough energy to do the work that we're thinking that it can do. Like right now, right, AI is pretty powerful, but most of it is, I think you even mentioned it, most of it is garbage as far as the information that's going into it. It's not vetted. It's purely whatever's out on the internet, on Reddit, on Facebook, whatever. The AI is scraping all of that off the internet
And I think
right
this
now, right?
point is the most important to highlight, that when you talk about AI, you think artificial intelligence. There's nothing intelligent about it yet. It just gives you the most popular answer. Even if you talk to something like ChatGPT, for example, you get an answer and then you can ask it, is this true, or what is it? And it usually gives you, well, I just gave you the most popular answer. That doesn't make it right. So you need to know those
Correct.
flaws.
Yes. But let me back up a little bit, right? The environment that the AI exists in is the internet right now. You see what I'm saying? That is the environment it exists in. So that's what's programming it. By default, it has to work that way. The environment programs the system at the level of coordination and pattern recognition and information diagnostics and all of that. What is everything that we've talked about up until this point? Hey, your environment, right? This is us echoing what we've been saying. Your environment programs your cells, programs the biology, programs the hormones, the neurotransmitters. Why? Because that's the environment you exist in or should exist in. Now, most people don't exist in the natural environment. They exist in an artificial environment. That by default is two different environments. That would be like taking AI and sequestering it, right? Before you release it out onto the internet so it can scrape all the information off the internet, you have to develop it in a lab and you start training it in a lab, right? That would be like living permanently indoors, right? You're only getting these very specific signals of the electrical power grid that modern man has made, the lighting that modern man has made. You're not getting the electrical input signals that should be training your biology, because biology is from the natural world and not it's not man-made. Biology is not man-made. So the inputs that are correct for it to do all its natural processes are natural. And all of the man-made inputs are, think of it like training it in a slightly different manner, right? In these two concepts of I train an AI isolated from the internet, and then I take that same AI and I put it out on the internet. It picks up different information. It starts to act differently, etc. Right? It's the same concept.
I can link it to
Now,
like real life stuff. It's like back home, we have a
yes,
concept, farmer strengths, which is basically means you're strong naturally. But only natural thing that was, you were just outside more.
Correct. You're outside more, basically doing the same thing that anybody does in the gym, lifting things, putting them back down, walking around with heavy things, sometimes just walking by yourself, etc. Right? All you didn't do anything different. The difference was the environment was giving different informational inputs, different electrical inputs to the biology that continues to power it up. And what it really does is it powers it up. It raises the voltage in the body, aka you are an electrical being when you're outside in nature. Because your body is biological and operates in nature, voltage goes up, aka you can think better, you can run faster, you can move, jump, etc. But at the same time, everybody that knows anything about electricity, when you raise the voltage, if the wires don't expand or the electrical grid doesn't expand, you create electrical resistance. That's currently the state that we're at in AI development. We are lacking the infrastructure to push enough power into the AI to actually make real artificial intelligence. Now, we humans and nature don't have that problem. Why? Because the infrastructure, right? So think of the infrastructure for AI is going to be global, right? We kind of know that. It's going to be all over the planet, power stations, servers, all of that is going to be all over the planet to power AI. Well, think of your body as the planet. So how many power stations, how many electrical grids, how many server stations do you have? Well, that's pretty easy to answer, depending on the species, up to, trillions and trillions of them, and they're called mitochondria. Mitochondria are the power transformation plants of the whole body. And what you've done is AI is looking at it this way. Now Elon Musk just maybe 2 days ago tweeted what I'm about to say, right? Right now, most people in the AI development space are thinking big power structures, right? Big power plants, nuclear power, solar power. China's going. So they're centralizing the power hub. What does that mean? That means by default, the wires that are going to be feeding the AI, they have to be massive, right? Because you're going to run large power from one central place to the AI. So now you need, in order to lower the electrical resistance, you need large wiring. It's very expensive. It's very hard to do. Guess what? It's much more efficient to do it the way biology does it. How does biology do it? Does it? It splits the current from one channel into trillions of channels. Trillions. That's every single one of your mitochondria. That's lowered the electrical resistance of the wiring. Now you don't burn anything up. And by default, you can run higher voltage with very low electrical resistance. It makes you very efficient. Just as a comparison, how efficient does it make you? Your brain runs on like less than 20 millivolts, okay? And AI runs on trillions of volts, hundreds of volts, thousands of volts, right? Or so if you just compare those two, you're orders of magnitude more efficient at lowering your electrical resistance to power the electricity in your neurons, right? AI is never going to be able to do that in the way that most people are thinking that they're going to power AI. Guess what? Hit Elon Musk in the head 2 days ago. He said, wait a minute. If it's just about power and getting power everywhere, why don't we just make multiple channels? Guess what he came up with? If I can put an AI server, a mobile one, in every single electrical car that I make, I now have trillions, or the potential of trillions of parallel power channels powering our AI. He came up with the exact same idea that biology came up with billions of years ago. Split the electrical resistance through multiple channels. Now you can expand artificial intelligence and biology. And that's exactly what happened. It happened 65 million years ago at the GOE, Great Oxygenation Effect. If you look at, prehistory, biological history of the planet, when oxygen rose, all of a sudden it went from single cell organisms to multicellular organisms, and almost overnight in terms of history, exploded with variety, right? It exploded with different forms of AI or intelligence, right? And they're all picking up their own information from their own environment, whether it's the ocean or the forest, etc., right? But point being, the moment that nature figured out how to make multiple channels to reduce electrical resistance through the mitochondria, it allowed for more complex life, aka artificial intelligence.
Yeah, you just sit here and it's like, what the hell are you talking about? Because this is a thing that people kind of need to get a grip with, that what Elon does is he never did electric cars. He's so far beyond of what it actually is, what he does, collecting
Oh yeah.
information, passing on informations, and transferring everything inside out. Uh, and again, it's everything that we already have feels like we are just reverse engineering this to put in front of us in a form of
Mm-hmm.
AI now. So
Mm-hmm.
so we can do that without doing it ourselves anymore. But to me, it raises the question, because we know we have had so many absurdly intelligent people. Where are they disappearing now?
Yeah, that's a good question. In my personal opinion, the really intelligent people are being programmed slightly different, right? So, and again, this goes back to biology is AI, right? So, um, let's just back up for just a moment, and I'll answer that question, right? You are an AI, and I am an AI. Every day, I'm learning new things, right? Whether it's something I've read, something I've experienced, etc., right? No day is the same, right? So you and I are AI. We learn real time, and that goes for every human being on here, right? Now, because of that, because of what we read, what we experience, that's what programs us. My child is an AI, and that, think of it like, instead of being my child, it's an AI I develop, right? Think of me and you are going to make an AI. We got to give it all the inputs for a long time before it even becomes useful at
Well, we
all
have
for
our
us,
own
right?
already.
Right, exactly,
We
right.
teach
And
it to
and
it,
we've
right?
been training it for how long? 2 years worth of information, maybe longer, 3, 4 years worth of information, right? So think of it that way, right? Your child is an AI, and you're feeding it information, and the environment is feeding it information. The moment you give up your ability to give it information or allow it into another environment, aka, I don't know, public schools, something like that, right? You have now by default taken that AI and put it in the internet, right? It is now capable of scraping all of the information off of the internet, whether it's correct or incorrect. It doesn't matter. It doesn't care. It's artificial intelligence. It's just picking up information, right? What tells it to do anything different is more along the lines of how does it coordinate the information, right? So think of it like biology. Let's think of it like this. Everybody's probably pretty familiar with a term called a cytokine, right? Because of COVID and all of that. If you have a cytokine storm, you're going to, be in trouble, et cetera. And that has incorrectly led people to assume that cytokine means inflammation. That's not true at all. Cytokine is a communication protein. When cytokines go up, that means that the brain now has to pay attention to wherever those cytokines are coming from, right? Think of it like this: is if there's a storm, right? If there's a storm a couple miles away and there's a lot of lightning, I'm hearing the thunder. That's the cytokines. It's the sound, right? I'm hearing the thunder. That's the cytokine. Now, most drugs, because medication or medicine is, oh, cytokines go up and that's a bunch of bad things, they're trying to make drugs to target the cytokines. That's like saying, oh, I'm going to put earplugs in so that I don't hear the sound of the lightning, right? I'm blocking the cytokine. I'm changing the cytokine. I did nothing for what's going on over there. A cytokine is a communication network. And that is what literally everything that most people focus on when it comes to longevity, like NAD plus or there's a specific thing for longevity. It's a protein called GDF15. GDF15 goes up as you age, right? So they're like, oh, that's a bad thing. We want to control GDF15. Well, GDF15 is also a cytokine. What's it doing? It's telling the body this is how much electrical resistance is happening in this person, and as you age, by default, electrical resistance is going to go down. You're going to become less efficient, right? So GDF15 is telling the body the current electrical resistance of this biological creature, right? You start making drugs that change that GDF15 or lower that GDF15, now you've messed the whole system up. The system might interpret, oh, this person's electrical resistance is really low. Let's run high voltage, right? Let's run really high voltage to power this person up. And guess what you end up doing? You end up burning the wiring. You end up with some kind of a disease at some kind of a level wherever the cytokine storm was occurring. That could be at the pancreas and develop insulin resistance. That could be at the brain and you develop Alzheimer's or Parkinson's, right? It's all about electrical resistance, and the electrical resistance in the body is controlled primarily by your mitochondria. How many mitochondria you have, or people call it mitochondrial density, right? And the environment that's tuning the mitochondria, right? Those are really the inputs that matter so that your body can accurately assess your electrical resistance and adapt its energy transformation systems, all of them, whether it's creating ATP or creating testosterone or creating creatine stores, all of that stuff that's all energy transformation, right? So think of it this way. How do I get the most out of a pound of wood, right? If I burn it, right, as a fire, I'm going to waste a lot of energy as heat and light and all of that. But if I put it in a really controlled chamber and make really small reactions, I can make that pound of wood last energy-wise for a very, 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 very long time, right? That is exactly what mitochondria are doing with all these other things like ATP and hormones and neurotransmitters. Those are all energy, aka sunlight, food electrons, cold electrons, all of the electrons from your environment and your food are coming into the body. If your body just burned it all up, you'd fry, right? So what it does is it takes that, puts it into the mitochondria, and the mitochondria make things with it. They're storing the potential energy as now chemical energy. They transformed it from electron energy to chemical energy that can now be controlled into hundreds and thousands of reactions so that you become incredibly efficient at powering that system. Does that make sense? As far as how mitochondrial density dictates the potential of raising how many reactions it takes to squeeze all the electricity out of everything that you're interacting with.
It just highlights the importance of what we always talk about is like the fitter, healthier you are, the more you're gonna get out of anything. And that baseline should always be looking for how do I get healthier, not what drug should I take, how hard should I train, and everything else, but it's kind of how can I improve my body's ability to deal with stress before I do anything else extra, because otherwise you just overrun everything too fast
Mm-hmm.
and
Mm-hmm.
nothing is gonna make any sense to your body. It's like sitting there and you talking to ChatGPT to absolute nonsense without structure about what you're gonna actually ask it and where you're gonna go with
Right.
it.
Yeah, because that's the power of the prompt, right? Everybody knows this in AI. Like if you're using AI, the prompt dictates the outcome, right? If you ask it a stupid prompt, you will get stupid information. It's really that simple, right? Everybody's kind of figuring that out with AI right now, right? And that is actually no different than talking to somebody who has been artificially intelligent, trained by, I don't know, a government versus somebody who is independent and can think independently. Just talking to them, when you ask this person the same question as you ask the other person, if you don't word it differently for the person that doesn't understand where you're coming from, you're going to get an answer that has nothing to do with what you're trying to talk about. Whereas another person might go, oh, you know what? This person, they're going to adapt, right? That is actual artificial intelligence. AI is not capable of doing that right now because its electrical resistance is too high. It can only output dummy information. What does that mean? That means it's not as evolved. That is actually what cancer is, right? Think of it this way. Cancer is defined by a Warburg metabolism. What does that mean? That you're burning a lot of sugar. Not you specifically, but the tumor, right? The tumor, the cancer cells, right? And so what does that mean for those cancer cells? That they have de-evolved, right? Before the great oxygenation effect that happened 65 million years ago, that is a clear point in time where from that point back, it was all simple life forms, one cell organisms, right? Why? Because they did not have mitochondria. They could only work on the the PPP, which is the pentose phosphate cycle, or the glycolysis cycle. That's the only way that they created energy, right? So these cells that now become cancerous, that's exactly what's happened. Their mitochondria have been poisoned or staled or burned up to the point where it's minimally functioning. So it is heavily dependent on the previous evolutionary framework of glycolysis and pentose phosphate to keep living, right? Because the cell doesn't want to die, right? And if it can find a way to make energy, it's going to do that, and it's just going to do it through the Warburg effect. What does that also mean? What does consciousness mean, or intelligence mean? It means that you can coordinate. That's what it means, right? Like, for example, if I asked you whether a tree is conscious or not, what would you say, Juris?
Well, to me, it would be, from what I know, has some kind of intelligence because it obviously communicates with each other and all that kind of stuff. But at the same time, it doesn't have much of control of everything else like we do.
Correct. So, but you would say that it's intelligent enough that I would classify it as conscious. The difference is that people think conscious is you're awake and moving. That's not what conscious is. It means that you are aware at a certain level. Trees are aware at a certain level of what they are and what they can do. The leaves move, the trees bend.
Which
You see
tree
what I'm saying?
was
Like,
in Africa that it becomes poisonous when it feels a giraffe coming? So giraffes always go
yeah.
from opposite side of the wind to eat it because it only gets
Mhm.
poisonous when it feels the animal present. I forgot the tree name, but
Yeah. So,
it
so,
is in
so
Africa.
point being, they are definitely conscious. They're just not conscious to the level we are. What does that mean? That's exactly how AI is right now. It's definitely AI, but it's not artificial intelligence yet. You see
Hmm.
what I mean? It's like a tree. It's at that evolutionary framework. That's exactly what cancer is. It's degrading its consciousness, right? It's no longer able to cooperate with the whole system, aka your whole body. It can no longer integrate because it's lost its intelligence or its consciousness. Why did it lose it? Because consciousness is dictated by electrical current, right? Let's put it this way. What's the definition between alive and dead?
Well, one has consciousness, one
Electricity.
doesn't.
Exactly. And that consciousness is dictated by electrical current, right? That's how we know you died, right? Your heart and your brain, right? Because you can hook up somebody to a machine, but it's providing the electrical current, right? Or I mean the physical pumping, but you can't hook up to, like, if somebody goes brain dead and you unhook them from the machine, they die because they are no longer able to keep the electrical current running because their electrical resistance is zero, right? Their electrical resistance is zero. It means they cannot make any transformation anymore. So um, the cancer cell is literally right before death, but because it's a cell, it can just de-evolve, right? So when it goes to glycolysis, Warburg cycle, it's just de-evolved to the point where it no longer has the intelligence to know that it's part of your pancreas, right? If you have pancreatic cancer, right? It's just sitting there doing the energy transformation that it can, but the electrical current in it is so low because the energy that it can create is so low because it can no longer use the mitochondria that its consciousness has lowered. Right? If you raise the electrical potential by lowering the electrical resistance, aka you bring mitochondria back on board to those cells, guess what? Those cells now can become conscious because they can raise their voltage, and now they're like, oh, we're powered up again. We know where we're at. We know we're part of the liver, or we know we're part of the lung, or whatever, right? So that is how consciousness operates. The bigger the voltage and the lower the resistance, the more conscious you are. Or in other words, in a biological way to say it, the more intelligent you are. So as you start to see the grid of whatever's powering AI, you'll see that AIs that become the most advanced are the ones that use the concept that Elon Musk just put out, which is multiple parallel channels powering the AI. The moment you start seeing that, That's when AI will start to leap into its next evolutionary thing. And we see that in biology through this concept of plants to animals to higher chain animals to primates and then to us, right? Basically, what we see is mitochondrial density goes up and up and up in the brain, right? From plants to animals, it's a big difference. Mitochondrial density from them to them, it's a quantum leap. And then from each animal up the chain of intelligence, mitochondrial density goes up, right? So the electrical resistance goes down, but the voltage goes up, the potential voltage in that biological system, right? So that's all that evolution is. It's figuring out a way to squeeze more energy with less heat, right? Less energy loss by dumbing that, by making it a multi-hundred step process of burning up the electrical current that it's got. And it does that through the mitochondria.
And this brings us to kind of explaining why people who are physically fit and physically active are usually capable to handle more stress, number one, and more often than not, they are almost wiser, like more intelligent. You have your Muhammad Ali's and everything like that. But even Mike Tyson, you look at him as like brutal animal, but when you speak to him, so goddamn intelligent, it's insane.
Yeah, yeah. And the reason why is because they are exponentially lowering their electrical resistance and raising their voltage. And I'll explain it in a very simple way. Most people think that you only get energy, electricity from food, right? And if you've listened to us, you know that that's not true, right? But the moment you introduce multiple levels of gathering electricity, you've essentially split the channels at the input side, right? So we've talked about the mitochondria being parallel channels in the body, right? Parallel channels of how electricity can run parallel inside of you. But what about the inputs getting into you? Right? If you only have one, aka food, you're going to need a shit ton of food. You're going to need a lot of food to power that whole body, right? But if you can split the energy input into the body through parallel channels, you've lowered resistance and amplified voltage. So a fit person, what do? They eat well, right? So they have the food part covered. But what do they also do? They're going to do some physical activity. What is all physical activity? Piezoelectricity. That's input number two. So there's food, piezoelectricity, input number two. Now you have two channels, right? You've essentially doubled your potential, you've cut in half your electrical resistance and doubled your voltage just by doing that. Now you introduce sunlight. That's a third channel, right? You introduce cold. That's a fourth channel. You introduce what's called cohesive network. So water holds tension, right, in your body, right, because it touches everything, right? So tension is what's called potential energy. That's a fifth channel, right?
Well,
And there's
hydration
many,
itself,
many more.
right? Because a lot of
Yeah,
people feel like massively different just by adding a bit more extra fluid in their stuff.
yeah, and exactly. Now you have water. That's number six. Water is like a battery, right? So now it collects energy, holds energy, electrons, aka sodium, potassium, all of those electrolytes, right? And it holds glucose, another energy source. So that's six parallel channels right there on the input side, right outside of your body. Six potential electrical channels that I just described. All of them pretty easy to exploit. There are a lot of other ones that are a little bit more eccentric and require a little bit of a background of quantum biology to understand how they work. But for the most part, people can kind of understand those six. That's six potential channels, and most people are only focusing on one.
What you just
Does that
described is
make sense?
going on a holiday. That this is why you feel so good when you're on holiday without even eating as much.
Yeah, because you've lowered the electrical resistance. Most people think that that's called de-stressing, whatever you want to call it. That's exactly right, right? You're de-stressing the system because think of it this way. If you're trying to funnel a whole bunch of energy through one channel, there's going to be a lot of resistance there. AKA, you're going to be stressed. You're going to be setting off cytokines. You're going to be setting off cortisol. You're going to be setting off a lot of things when you're trying to do that. But if the moment you split it into multiple channels, you lower resistance, AKA you've lowered stress. Right? These are all synonyms, but they are all based on physics. Physics is what's dictating how easy this is to modulate and control.
Yeah, and in real life, we can see it that we can overstimulate, we can overtrain our body, we can kind of get excess information in our head, and you're not going to learn something just doing it one day, all day through. You need a little break, reset, and so on and so forth. And AI is exactly the same. If you keep prompting it without getting an answer first, it's just going to crash. It's just going to come up with a lot of nonsense. How would you link what we have access to with what we already kind of know of our human biology to use AI as a tool to enhance our physiology and just energy capabilities and stuff like that? Because, like I mentioned in very beginning, it's understanding the limitations of AI. There are still a lot. The information it gets from is usually blogs, not even relevant stuff and stuff like that. We also know like medical journals more often than not are just absolute nonsense. And if you don't understand how to read
Yeah.
medical journal and analyze it, you're gonna end up being one of those people who is sharing this post about how if you drink energy drinks, you're gonna die. And you're like, yeah, read the actual study. They dunked
Right.
a cell into energy drink for 72 hours straight and it died. Anything drained, put into anything for 72 hours is going to die. It's not energy drink.
Yeah,
So,
it's not going to
yeah,
work.
yeah. So how do you link and
Yeah,
combine
so I
both
would say
to make the most out of it?
yeah, so as far as right now, I think that the most useful part of AI is physics, right? Physics cannot there isn't like, oh, we only use this part of physics, right? Physics is physics. That's what governs everything. That's if you do not obey the laws of physics, by default, you don't exist in this universe, right? That's how solid physics are. Now, the quantum physics and the edge of what it can explain, that's to be debated. But I'm talking about the physics that govern everything that we know of planetary systems and the Earth, et cetera. That's all governed by physics. AI right now knows a lot about physics, everything that it needs to know, right? Even to the point where that's actually where AI is being the most useful in industry right now. Quantum physics, space travel, AI is being very, very useful in that space. And that is what I think AI is going to be useful for. Energy-based diagnostic therapies, the things that we've been talking about, light therapies, electromagnetic therapies, those therapies are going to modulate the input channels into the system, right? What I just talked about. How do you make or lower the electrical resistance? Because that's at the end of the day what you should be asking AI. At the biological level, how can I bring up my voltage and lower my resistance, my electrical resistance? That is purely a physics equation, right? So if
It's
you start
almost like
training an
you are
AI, right,
you are giving a master prompt for somebody who wants to improve their health. Ask this.
right now,
Don't ask about calories. Ask about how to be more
exactly. Don't ask
efficient.
it about calories. Don't ask it about drugs. Don't ask it about any medical literature. It means nothing. Ask the AI to learn as much about physics as possible, specifically in how it relates into electricity and energy transformation. That is something that AI is currently an expert in. Then you ask it, in a biological system, all of these systems are dumbing down steps and creating this electrical resistance, what I've just talked about. Then you go, okay, how does a human lower its electrical resistance through parallel input channels and increasing parallel internal channels, aka mitochondria? And that is where the AI is going to start to shine. People that are smart enough to think this way are going to be able to exploit AI for longevity and performance at a much higher degree when they start thinking along these lines.
Interesting. And that's definitely not what anyone ever asks when they are talking to AI about health. Because I see so many go,
No,
oh, you gave me such a training plan and such a diet plan and this and that. And I look at it, it knows nothing about you. How can it give you anything? Like it's
exactly.
like picking up some muscular development from 90s and doing Arnold's 8 hour whatever workout. I'm like, it's great he could do it, but he probably never did it anyway.
Yeah. And then as AI becomes more capable of actually being artificially intelligent, then you can start to ask it dynamic optimization of energy resistance. In other words, hey, I'm going to be going through this particular scenario, whatever it is, right? Getting ready for a marathon, getting ready for a bodybuilding show, or, months of really hard mental work, right? Then you can start asking the AI specifics, because now you know the specifics of the requirements for the electricity, aka I'm going to be doing physical work. Okay, so now it's completely dependent on protein assimilation and all of that, or I'm going to be doing this other type of work. That dictates where the electricity that you're going to be gathering is going to be going. Then the AI can do dynamic optimization of that electrical circuitry, right? That is the real gold, where I think that people that start accepting this concept that I just talked about and exploiting AI on this concept can now roll it into biology.
Yeah, yeah. I think that's where we need to go to, because otherwise we're just asking really simplified
Superficial.
questions.
Yeah,
Yeah,
you're almost going backwards, right? You're looking at these steps and asking it how to optimize the steps, when the steps don't mean anything without the transformation stuff, right? The mitochondria in the body, and then the parallel channels outside the body. Those are first before the steps, right? Everything in medical literature right now is only focusing on those steps, right? The Krebs cycle or the cytokine storms. They're only focusing there. They need to be focusing way more upstream to where the energy transformation starts, because that lowers resistance and that optimizes the steps.
yeah. And anyone who's watched our videos, they already know a lot of steps, not just the six you mentioned, the deuterium depleted water and red light therapy and everything else like
Yeah,
that.
yeah, yeah, yeah,
A million things that you
yeah.
can
So,
do.
and that's what I'm saying. Like everything that I've been kind of elucidating with this becoming superhuman with you for the last what is it, 3 years now? Almost. It's been a
Something
long
like
time.
that, 3 or 4.
Yeah, yeah. Anyway, that whole thing, if you wrap it all up, I've been teaching you about the channels, right? The more channels you add into your life, the more parallel channels, the lower your resistance becomes, the bigger potential for voltage and keeping the resistance low, right? Then you start adding more specific things like the training that we might do and that sort of stuff. And you start amplifying mitochondrial biogenesis and all of that. And now you're starting to multiply the parallel channels internally, right? So that's exactly what we've been teaching you right from the very beginning, how to lower your electrical resistance through parallel channel assimilation.
And this is the secret to longevity. It's not so much
It
as
is.
long life, but having high quality of life for as long as possible by implementing all these little things, by understanding how biology works, by linking it and seeing real life processes that AI shows us, hey, if we do this, and then Elon comes up and tells you exactly what he's going to do next, hey, our body already does it. Let's do more of it, because Elon figured out this is going to massively speed up everything he does. Why would we hold ourselves back and not do more of that with our own body? Because we know we only have one. Well, we don't
Yeah,
know. Maybe we have another one somewhere.
yeah.
That's
Different
another topic.
reality, different consciousness.
But understanding this and understanding like how AI works really, really highlights about how human body works. And the reality is we are so far ahead biologically, like physiologically, than anything we have created so far. Uh, and why not use it in our advantage?
Correct. I 100% agree.
Awesome, David. Appreciate your time. I know I need to let you off. We're going to dig deeper in the next videos. I've got some topics lined up, and I'll see you next week.
Awesome, man. Thank you very much. This is